Hi, my name is Teagan. I am a software developer and consultant with Atomic Object. I'm going to be talking to you today about Retrieval Augmented Generation, or RAG for short. We use this for using LLMs with domain-specific data. So using an LLM is pretty comparable to hiring a fresh college graduate. They just went through a very long and expensive training process, and they know very little or next to nothing about your product or your company's internal data. Imagine you sat down a fresh new hire on their first day and you asked them, what was our average gross income in 2021? And you said, okay, here's 64 gigabytes of our past financial data. And by the way, you have 30 seconds to answer that. They're probably not going to be able to do that. It's very hard, comparably, for an LLM to answer the same type of questions. LLMs can't do it all. How do we enable an LLM like ChatGPT to answer domain-specific questions? A question that you might ask is, why don't we train a new model on our data set? Let's just completely train our own LLM. Well, this can be very expensive to achieve a really good, consistent result that we can rely on. Completely training an LLM from scratch can cost upwards of millions of dollars. The data can become outdated and we'll need a way to retrain that data as it becomes refreshed in our database. This also requires clean and highly curated data. So before we're able to actually train the LLM, we'll have to go through the data and make sure that that data is clean and ready to use as well. Another question you might ask is, okay, why don't we just send over the data set to the LLM along with the question? And the answer is that we won't be able to do that because LLMs have a max content window. Currently, ChatGPT 4 Turbo has 128,000 tokens, or words roughly, so you can't send multiple gigabytes of data along with your request. We also might not want to expose internal data on a network request like that, so that poses a security concern. Also, an LLM query is charged per input token, so that could get very expensive with a very, very large request. So at this point, you're asking, how do we leverage an LLM with your company's domain-specific data just to allow it to act like you're asking a question to a tenured seasoned employee? The answer to that is Retrieval Augmented Generation, or RAG. As you can see here, it's been getting some hype and some press, and rightfully so. It's a really great technique to enable LLMs to use your proprietary data. RAG is a way to allow an LLM to access data that's specific to your organization. You pretty much allow it access to your databases and your data sets to specifically target a problem that you're trying to solve. So we understand that we can't train a completely new model on our data, and we can't just send the whole database along with a request. So here's what RAG does to solve that problem. We're pretty much going to place an external data source in the middle of the transaction and create a pipeline to allow the LLM to access data that's specific to your organization or target to a specific problem you're trying to solve. So then when the user prompts the system, the RAG pipeline is going to retrieve the relevant data from those external sources and then pass them to the LLM to produce a context-aware response to the user. What we're doing here is we're transforming an existing data set into a vector database, which enables us to ask a question in plain text and return only the relevant results that exist in that database. Then once we select those chunks, we're going to pass that data with the question to an LLM like ChatGPT or Claude or whatever you're using for analysis and to provide a user-friendly response as well. So just a word on this diagram here. First, we're going to take documents or your database or your existing data. We're going to generate embeddings based on that data and store them all in a vector database. That's kind of like the first process that happens. And then for any request thereafter that a user makes to the RAG system that is presented pretty much just like ChatGPT, we're going to select those relevant chunks of data, package them up, and send them to an LLM along with that question. So let's get into some applications and use cases of the RAG process. These can be used by any company. You can store with RAG your manual documents into this database to allow the LLM access to answer those questions about your company processes. So this is going to increase efficiency on your HR team by allowing them to focus more on onboardings and the important stuff rather than answering random questions about 401ks and things that any employee might give them. Another application of this could be a legal assistant. You can store your legal documents in the RAG pipeline and allow your employees to ask questions about any legal documents, which would help translate the legalese, and the LLM could then answer casually on your very specific company legal documents, which is huge. You don't have to sit there and read through the entire document and try and understand what it's trying to say. It could cut through all of the legalese and answer in a user-friendly way. Another use case here is a financial companion. You can allow the LLM to access a history of financial results to analyze and draw conclusions on. For example, you could ask it what your quarterly earnings were on average in 2022, and it would be able to answer that for you and give a really fine-tuned answer based on analysis of the results. So let's get into an example of a very targeted issue that RAG can help solve. Let's look at an insurance company, for example. Claims that your customers make need to be routed to the different team based on the claim description specifically. And let's say you have a database of all the past claim descriptions and which team that they were routed to in the past. So with RAG, we can actually store that past claim data into an external database to be automatically searched upon, so that when a new claim is made, we give that new description to the RAG pipeline, and we use that input description to search for the past claims with similar descriptions that have the routing team attached to it. And then we can pass those return results to an LLM in order to draw a conclusion on which team the new claim should be routed to. So next, let's get into what the RAG implementation is going to look like. First, you're going to have to select an interface for your users. And this could be multiple different ways. You can integrate this into pretty much any custom application. It integrates really well. You can choose a web or a mobile client. Say if you have a mobile app, you can use your mobile client, or if a web app, you can use that too. Also, you can choose to use a chatbot interface too. That is, the little chatbot in the bottom right corner that pops up, and you can enable your employees to ask it questions, or even for customer support, you can allow your customers to ask questions too. Next is the RAG pipeline orchestration. This is usually located along with the user interface. So this is like all of the process that happens from the start when the user asks a question. We select those documents and then we send it to the LLM and return the result. This usually all happens along with the client. Next is data storage. So this is going to look like a vector database, and it's probably going to sit along with your already existing database or data stores. It's going to be pretty similar to your already existing application or your already existing database implementation. So next, you're going to choose an LLM. There's a lot of options out there like ChatGPT or Claude, where you can do API access and send an API request to the LLM to then receive a response. Or if you want to, you can create your own instance of an open source LLM like Llama. So next, let's talk about some risks and challenges that might present itself when implementing or using a RAG pipeline. The first being LLMs have a non-deterministic output. It's really hard to get responses to be correct 100% of the time. If you've used ChatGPT before, I'm sure you've seen this. It'll give you a different result based on the same question being asked. For this case, testing and validation can be really challenging because, we ask it the same question and it's going to give us maybe 5 different results. But you could use advanced techniques to improve the LLM output based on the data set and the use case at hand. Another concern is data privacy. This is something that pretty much any company is concerned about and will be concerned about. Say you have internal sensitive data, you might not want to send that in a request, in a network request, over to an LLM. Well, the good news is that there are open source LLMs like Llama that can be self-hosted internally so that you aren't sending external network requests. And this data that's accessed by the LLM is always under your control. It's not sent to any external place or anything, and if you want, it could also be self-hosted on your own machines if needed. As I look at it, there's 4 main costs to consider when you're implementing the RAG pipeline and then operating it as well. First off is the initial implementation of the RAG pipeline. This is a small to medium length custom project that you're going to undertake. This is a capital expense, a one-time initial expense. And just a note that this will take less time with a team that's experienced in using it. So next is the cost to embed your data set into a vector database. So this is split up into 2 costs. The first is a one-time cost for the entire current data set. And then the next is a recurring cost as data needs to be refreshed in the database. This is also relatively inexpensive, and it depends on the size of the data set as well. So it's hard to give a concrete number. Next is the cost per request to access the LLM. So anytime the user asks a question to the RAG pipeline, it's going to need to send a request to an LLM. So the cost for this depends on the volume of use, the number of users that are using your RAG pipeline. But the current cost is pennies per million tokens or words. So this is also a very relatively inexpensive cost. And then lastly, the cost to host the vector DB. This is similar to the cost that you're already incurring on the data that's hosted on your databases already. So next I want to talk about the return on investment that you're getting by implementing the RAG process into your organization. First off, the cost to experiment with this is very low. And this return on investment is going to look like increased efficiency across your teams in your organization. It's not going to be an upfront dollar value. It's going to look like more just this optimization that happens across your teams. Your teams are going to get faster and more effective at solving the problems that they face on a day-to-day. It also depends on which data sets are leveraged and the use case that is at hand. When I was talking earlier about the specific insurance claim situation, that might look like more claims that are delivered to the right team initially, rather than having to go to many teams before it arrives at the right team. So yeah, having worked on a project like this recently, it has opened my eyes on how much companies may be missing out on putting their data to work using this RAG pipeline. I think it's a very interesting new technology, and I just wanted to thank you for spending some time learning about it with me today. Thank you.